Hey guys, this is Mrs. Harbin, and today we are going to talk about the foundations of science and why we study life science. Be sure to follow along and fill in your notes as you go. If you need to pause or play back the video at any point, go right ahead. You can take as much time as you need. So let's talk about why we study life science. To do that, we first need to answer this question: what is science? Well, I've got two definitions of science for you. First, science is the knowledge gained through man's observation of the physical world. Those are the things we can see, smell, taste, touch, hear. Science is the careful and systematic study of the natural world. What that means is that we do it in an orderly fashion. We make careful observations, we record what we see, we do it in a way that is orderly, and we use those studies, those observations, to help us gain knowledge about the world around us. We also can use models as a part of science to help us understand the world around us. Models help us to study the world because they can simplify objects and processes that are complicated for us to understand. Now, models are subject to change as more knowledge becomes available. If you guys know anything about scientific history, you know that some of the first models of the solar system had the Earth at the center and the sun revolving around the Earth. As more knowledge became available, this model changed, and the sun became the center of our solar system, with the Earth going around the sun. So models are subject to change as we learn more information. A good definition for a model is that it's a simple representation of a much more complex idea or concept. It can be a simplified depiction of what something looks like, or it can model a process for us. Models can be flat drawings on pieces of paper, or they can have multiple dimensions. Here's an example of a model that you might see around the classroom. This is a model of a cell. As you can see, a cell is pretty complicated. There are lots of small parts to it, and this model or this diagram helps to show those parts in a way that's easy for us to see. Now, let's talk about how to think scientifically. Because you guys are going to be in life science all this year, you've really got to work on your scientific thinking. And to think like a scientist, you must have at least 3 characteristics. First is curiosity. Second is caution, and third is a commitment to certain presuppositions. Now, let's talk about those 3 in detail. You probably already know what curiosity is. It's important to be curious because a curious mind is one that likes to ask lots of questions. In fact, this is pretty much what scientists do. They ask questions, and then they try to go find the answers to those questions. Scientists do ask lots of questions, especially the why questions. They want to know why things happen, why things change, why things stay the same. So hopefully you've got a good sense of curiosity and you're ready to ask some great why questions. The second thing that scientists have to have is caution. Scientists know that not everything they read or hear is true, especially if it's on the internet. They're always very cautious of accepting new information and want to know where that information came from and how valid or true that information might be. Now, their caution is marked by 2 major features. First, their observations, and second, their awareness of the limitations of science. So let's take a little detour and talk about those 2 things. Observations are things that we experience with our 5 senses. Again, that's our sight, smell, taste, touch, and hearing. A lot of times we think of observations only as things that we see, but you can observe the world around you in other ways as well. Now, we do have tools to help us make observations. Microscopes, x-rays, microphones, all of these things can help us experience the world around us through our 5 senses. Now, not all observations are valid, meaning they're not all accurate, they're not all well-grounded. So scientists are cautious even of their own observations. Think of your own observations that you've made before. Have you ever seen something at a distance that turned out to be something totally different? Or like me, have you ever thought you heard one thing, but actually something different was said? So observations that we make are not always valid, and we do have to be careful and cautious when it comes to our observations. Good scientific observations are repeatable, meaning that if we're doing an experiment, if we're out observing in nature, we should see the same thing over and over and over again. After gathering repeatable observations and information, scientists then make an inference. So let's quickly talk about the difference between the two, an observation versus an inference. An observation is information, like we just said, gained by using one or more of one's senses. An example might be dogs average about 25 miles per hour when they run. This is an observation you can make by watching a dog, by timing a dog, by recording it as it runs down the street. You can gather this information and make that observation. An inference, however, is a little bit different. It's a logical conclusion based on what has been observed. So let's say we watched two different dogs run, this dachshund on the left and this greyhound on the right. We can then conclude that they run faster, greyhounds run faster than the dachshunds. Or maybe sometime in the past we've seen a snail crawling along the ground. We can come to the logical conclusion that dogs move faster than snails. So let's do a little test. This isn't in your notes. You can just follow along and try to answer as we go through. Is the statement an observation or an inference? Laura's cat had 8 kittens. Right? You should have said that's an observation. That's something that Laura saw with her own eyes. She probably touched all 8 of the kittens as well. So she's experienced that with her 5 senses. What about this one? The neighbor's calico cat had 6 kittens this spring. Again, that's an observation. You probably know that your neighbor's cat had 6 kittens because you saw them with your eyes and maybe you held them and you experienced that with your senses that way. My cat had 4 kittens. All right, that's another observation. Again, something you've experienced with your 5 senses. What do you think about this one? Most female cats will have 6 kittens. That one is an inference. Because we have most female cats will have, it's not something that we can see right now. We're not saying all cats have 6 kittens, but we're making a logical conclusion based on the numbers that we've seen from Laura's cat, our neighbor's cat, and our cat. We made a logical conclusion or an inference that cats will have about 6 kittens. All right, last one. Laura's cat should have 6 kittens next year. Again, hopefully you said that's an inference, that's a logical conclusion that we've made based on this other information that we've gathered. Nice job, guys. Remember, we said another part of caution is this awareness of the limitations of science in addition to our observations. So let's talk about those limitations very briefly. We know that science deals only with observable evidence. Example, bluebirds are blue in color. Science can't prove a universal statement or a universal negative. They can't use words like all, no, never, and always. For example, scientists can't say there are no dinosaurs on the earth today. Just because they've never seen a dinosaur doesn't mean they've explored every inch of the entire globe, from the depths of the sea to the heights of the mountains. Just because they've never seen it doesn't mean they don't exist, so they can't prove universal negatives. Science also can't make a value judgment. Like, they can't tell the worth of something like goat meat is delicious or Chobani oat milk is wonderful. Those are matters of opinion and not observable facts. Another thing that science can't do is that it can't provide final answers. Like, the model of the atom is always changing as new information becomes available. We talked about that previously when we talked about the model of the solar system, how people used to think that the Earth was the center, and now they think the sun is the center. This model has changed, so science can't provide those final answers. Some other limitations that science has: scientific observations may be faulty. The tools that we use may malfunction, or humans may make mistakes, like me if I mishear you, or maybe even a mistake is made in an observation or in recording data. Also, scientists are influenced by bias, and a bias is what someone wants to believe. Here's a great example. There's a man who works for a company that makes cancer-fighting drugs, and he's experimenting with a drug that he believes may fight skin cancer. He must be careful not to set up the experiment or misinterpret the data just because he really wants the drug to work. He has to record the facts as they really are, not just what he wants them to be. The third part of thinking scientifically is having a set of presuppositions. Anyone who wishes to think scientifically must be guided by certain presuppositions. And if you've never heard that word, a presupposition is an idea that a person takes for granted, something a person assumes to be true without having convincing proof of it. You probably aren't even aware of all the presuppositions that you have. So here's an example. We all have this presupposition that the natural world is a very orderly place and that there are rules that govern what happens in nature. The orderliness of nature can be known by us humans, meaning the rules can be found and seen by us through scientific observation. We all operate on that presupposition and all throughout science, so we must be aware of those presuppositions. Presuppositions then come from our worldview, and our worldview is the perspective from which a person interprets all evidence in life. From a Christian perspective, there are only two worldviews from which to choose, the Christian and the non-Christian worldview. Let's talk about these two, Christian and naturalistic worldviews, the most common worldview among scientists. The Christian worldview holds to these presuppositions. God is eternal. Humans are special creations of God, made in his likeness. Pain and suffering are the result of sin in the world. God's word determines right and wrong. God is the source of redemption, and people can use science to help others. And there is life after death. The naturalistic worldview, however, holds these presuppositions. The universe is eternal. Humans are advanced animals that exist through evolution. Pain and suffering occur by chance. Mutual agreement determines what is right or wrong. Science will rid the world of ignorance and help people. This life is all there is. As you can see, these two different worldviews have very different presuppositions. And based on what presuppositions you believe, your understanding of science is going to be guided in one direction or another. Now, the three major teachings of a Christian worldview are this. God made the world and everything in it. The world has fallen into a tragic state because of sin, and God is working to redeem this world to himself. Because of this worldview and a few other things that we find in Scripture, it affects how we, as life scientists, will study life science this year. So let's look at how God's work of redemption is related to the study of life science. First, life science helps us to relieve human suffering and thus proclaim God's truth more effectively. Because we're helping to care for creation, people will listen to what we have to say. By studying life science from a Christian perspective, a Christian can learn how he may work to make his part of God's world obedient to Christ, whether that's caring for animals or caring for a garden. And 2 Corinthians 10:5 says this, "We demolish arguments and every pretension that sets itself up against the knowledge of God, and we take captive every thought to make it obedient to Christ." Every thought includes the thoughts of a scientist, and we need to make sure that every thought that we have as a scientist is aligning with our Christian worldview and presuppositions. Another thing to keep in mind as we study life science is the creation mandate. The creation mandate, which comes from Genesis 1:26-28, says this, "Then God said, 'Let us make human beings in our image and likeness, and let them rule over the fish in the sea and the birds in the sky. Let them rule over the tame animals, over all the earth, and over all the small crawling animals on the earth.' So God created human beings in his image. In the image of God, he created them. He created them male and female. God blessed them and said, 'Have many children and grow in number. Fill the earth and be its master. Rule over the fish in the sea and over the birds in the sky. Rule over every living thing that moves on the earth.'" You can see right from the beginning that God made us male and female, unique and special creatures. Then he proceeded to have us be in charge of the rest of his creation. This is also known as the dominion mandate, because we are supposed to rule over and care for everything that's been created. So, does the creation mandate allow us to use creation in any way that we desire, however we want? No, not at all. Although that man has been given dominion over the earth, he shouldn't abuse it or be cruel to any creatures or humans. We're to care for the plants, we're to care for the animals, we're to care for everything that God has created, because he's made us stewards of his creation. So keeping all of that in mind as we study life science, this is our overarching goal. We will learn to care for God's creation